Okay, so welcome back. Now we're going to use Newton's method to approximate all of these values, these intercepts, okay, or these approximations. Okay, so we're going to do 1, 2, 3, 4, 5 iterations of using the formula. So realize that we're going to start with 2, okay, and then we're going to approximate using the formula and see what we get to here. Now, the way you do this on the calculator, and again, with the homework and stuff, practice using the calculator, okay? So the way we're going to do this is you use x0 to find x1, and then you store it in your calculator, and then use the value for x1 in calculating x2, and then store that in your calculator, so you're always using the value stored in the calculator. Okay, so there's no rounding error as far as our purposes go. Now realize that the calculator only displays, I think, 10 digits, but it will save, I think, up to 32 digits in memory. Okay, so here's how we do it. So we're going to go from 0 to 1, so here's f. So let's start with finding f prime of x, which is 3x squared minus 3. So we got f of x and f prime of x. Okay, now what we're going to do is we're going to estimate x1. So x1 is equal to x0 minus f of x0 over f prime of x0. So that's going to be 2 minus f of 2 divided by f prime of 2. So what are we going to get? Well, we get 2 minus what? We get 8 minus 6 plus 1 over 12 minus 3. Okay, which equals 1 minus, what do I get? We get 3 over 9. Okay, or 1/3. Oops, not 1, it's 2. 2 minus 1/3. Okay, which we know is equal to 1.67, 6666 and on. So, which is equal to 1.6 repeating. Okay. Now we save that in our calculator. Now what we're going to do is then I'm going to show you. Now I'm going to write down the answer, but I'm going to show you the same formula. So now find x2. We're going to do x1 minus f of x1 divided by f prime of x1. And so that's going to be, well, x1 is 1.6 with borrowed. So this is why you want to store this in the calculator, because you're going to want to eliminate the round off error as much as possible, because it will have a compound effect and it will affect your answer. So then we want to do f of x1, right? So f of 1.6 with a bar over it, divided by f prime of 1.6 with a bar. Okay? Now, if you stick this in your calculator, you will get approximately 1.54861111. Okay? And then again, if you do f3, which is equal to x3, which is equal to x2 minus f of x2 divided by f prime of x2. Well, if you put that in your calculator, you're going to get approximately 153239. 1.532390162. And if you keep going, x4, which is going to be x3 minus f of x3 divided by f prime of x3 is going to give you approximately 1.53208 89. Okay, and then finally, if you keep going, you'll get x5, which is going to be approximately 1.5320820. So 1.532088886. And then if you do, now they don't ask it you, but if you go on to x6, you actually get the same 10 digits on your calculator. So which tells you that for anything bigger than 5, you're going to get the same thing on your calculator as x5. Okay? So notice how as we do the iterations, we're getting closer and closer, we're getting better and better estimates for the 0. Okay? And so notice how these digits don't change after the 5th iteration. Okay? And so we would say that the root, so x5, we would say the approximate root on the interval from 1 to 2 is approximately 1.532088886. 88886. Okay, that's it. Have a good day.